In this video, we're going to learn how to balance a half reaction using basic electrolyte rather than acidic electrolyte. So let's begin by figuring out whether our half reaction is an oxidation or reduction reaction. We know that every element, as long as it has no charge, is going to have an oxidation number of 0, so lead metal starts with an oxidation number of 0, and we can figure out the oxidation number of lead in this polyatomic ion by using the oxidation numbers of hydrogen and oxygen as being +1 and -2 respectively, and since there are two oxygens, -2 times 2 is -4. The one factor to keep in mind is that this polyatomic ion has a charge of -1, which means the oxidation number of lead here must be equal to a number that is added to +1 and -4 in order to make -1. So this means that the oxidation number of lead must be +2. Since we're going from 0 to +2, that means that our oxidation number is increasing, meaning that lead has lost electrons, and therefore we are dealing with an oxidation half reaction. Therefore, in our balanced redox reaction, or our balanced half reaction rather, we would expect to see the electrons as products rather than as reactants. So let's go ahead with balancing it and see whether this is true. Now, the good news about balancing in base is that all of these steps for balancing a half reaction in acid are done exactly the same way. So let's go through with those before we find out what needs to additionally be done in order to convert it to a basic electrolyte. So if we start with the major atoms, the only major atom is lead, and we have one lead atom on each side, so this is done. Then the next thing we need to do is balance oxygen by adding water molecules. We see there are 2 oxygen atoms in the products, which means we're going to add 2 water molecules to the reactants, and that will allow oxygen to be balanced out. But of course, when we add water, we're also adding in hydrogen, and even though we have one hydrogen atom on the product side, hydrogen still isn't balanced, so we can balance hydrogen by adding H+. There are 4 hydrogens in the reactants and only 1 in the products, meaning that we can add 3 H+ ions to the product side, meaning that all we need to balance now is the charge. So we see that our reactants have a total charge of 0 because neither lead metal nor water has any charge. We have 3 H+ ions, but our polyatomic ion has a charge of -1, so -1 plus 3 is still +2. So to get this equal to a charge of 0, we need to add 2 electrons to our products, and now the charge is balanced as well. So up until this point, we've just followed all of the steps for balancing our half reaction in acid, and now we need to cancel all of the H+ ions and somehow replace them with OH-. So how exactly do we do this? Well, we know that all H+ comes from water because H+ is in perpetual equilibrium, or water is in perpetual equilibrium with H+ and OH-, because all acid and all base come from water here. So if we know that we have 3 H+ in the product side, if we add 3 water molecules here, that would mean that we are adding the equivalent of 3 H+ and 3 OH- to the opposite side of the reaction. And if we do this, not only are we not changing the mass of either side because we've added 3 water to both sides just in different forms, but because +3 - 3 is 0, we're also not imbalancing the charge. Now, because of this, we can cancel a few of the compounds that appear on both sides of the reaction. So, the whole point of adding this water here is to get 3 H+ in the reactant side so that we can cancel the H+ in the products, and that's exactly what we're going to do. Secondly, we can also cancel the 2 water molecules in the reactants here and cancel 2 of the 3 water molecules that we added here. And if we rewrite this equation so that it is more easy to read, we would have 3H plus our lead in the reactants because the water and H plus cancel each other out. And then we have our lead polyatomic ion here, followed by 1 water molecule and 2 electrons. So if we double check whether everything balances, we have 1 lead on both sides. We have 2 plus 1 is 3 oxygens on both sides, and 2 plus 1 is 3 hydrogens on both sides. And if we take a look at the total charge, we have 3 OH minus, which means we have a total of -3 charge in our reactants, and then we have 2 electrons plus the negative charge from the polyatomic ion is a total charge of -3. So even though we added this additional water here, as long as we added the right amount to exactly cancel out our H plus, and as long as we canceled out the compounds or species on both sides, everything should remain balanced, and we can see here that there is no H plus present, and therefore that we're using OH minus to balance charge rather than H plus. In the next video, we're going to look at how to combine the balancing of individual half reactions in order to balance an overall redox equation that contains both an oxidation and a reduction half reaction.